Good afternoon. Welcome to E391 MM391. Welcome to this afternoon's lecture. This is uh, Maintenance Reliability and Engineering Economics. Um, Thank you for joining in this afternoon's lecture. We are in week 12 and today is lecture 2, week 12, lecture 2. For those of you who have not done so, if you could kindly please put your name and student number in the if you could put your name and student number in the chat box, please, if you have not done so. If you've already done that, then that's fine. Guys, there was one question. There is one question um, earlier today was from Mr. John Chief. He's asking if the short test about the short test coverage. Firstly, the short test will be on next Friday, 19th. Right? It will be on Friday, 19th November. That's week 13, and basically it will be online. The coverage will be all on engineering economics, right? The coverage will be on engineering economics, and the weight is equals to 6%. All right. Okay. So we are only looking at, when we are planning this test, we are only looking at exams for final year, right? We are planning with regards to final year. Guys, don't worry if you have some issues or problems. We will give you a window. For example, there will be a I'm just giving you an example. There will be a window during which the Moodle will be open. The Moodle test portal will be available, and then you can enter into the test portal, but the test in itself will only be 1 hour. All right, the test in itself will only be for 1 hour, but the portal will be available for maybe 2 hours, so you can enter the test anytime. All right. Okay. Let's continue with our problem which we were looking at. I would like to share my screen. By the way, Hafiz and Bhavish, you guys can hear me? Is Bhavish here? I think Bhavish is not here. Hafiz, all right, both of these boys are not here. Anybody? Amit, can you guys hear me and see me?
Yes, sir.
Okay, right. Thank you. All right. Let me now just share the screen. I'm going to share and have the Microsoft Word uh, online. Are you able to see the Microsoft Word document? Hello?
No, sir. It's just your home screen.
Okay. Thank you. Share that again. Can you guys see my Microsoft Word document?
Yes, sir.
All right. Thank you.
Yes, sir.
Okay. Right. So we were looking at this particular problem. Let me just place today's date and time. So today we are doing the 9th of November, and this is week 12, lecture number 2. Now we were looking at this problem. A manufacturing firm is considering which of the two electronic devices to install to reduce costs. Device A cost $100,000 with a useful life of 10 years. It can be expected to result in $60,000 savings annually. Device B costs $250,000 and will have an associated cost of $200,000 in the first year, $180,000 in the second year. Okay, so associated cost savings. So your savings gradually decreases. This sort of reminds me of when I bought my Toyota Prius. In the beginning, my Toyota Prius used to save me maybe about $70 worth of fuel per week. Now it's only saving me $50 worth of fuel per week. This is a true story. Okay, yeah. So yeah. Okay. So in order to see the actual the annual worth, you see the question says use an MARR. MARR, the minimum acceptable rate of return, is set by the company. The company wants that it should have a minimum rate of return of 10%. Okay, so how do we handle this particular situation? We have to use annual worth method of analysis. So let's go device A. We were able to draw the cash flow diagram. There's a minus $100,000 investment in the beginning because it cost $100,000. Then thereafter it gave an annuity of savings of $60,000 per annum. And then we were able to see that the annual worth for device A is equal to that much. Now let's have a look at device B, guys. Let's have a look at device B. Alright, so let me just copy some of this. Okay. Alright. So what is the first cost for device B? The first cost for device B, the investment cost is 250,000. Yes, 250,000. Right? Useful life 7 years. Okay, useful life 7 years. Useful life 7 years. Savings. Can somebody tell me about savings? Savings would be as follows. Savings first year, how much? First year 200,000. Yeah. Second year
180,000.
Nice. Who's answering? Who's answering? Can I just note your name now? Andy.
Yes, sir.
Okay. Third year
160,000.
160,000. Fourth year 140,000. Fifth year 120,000. Right. Sixth year, very simple, 100. And seventh year
80.
Yes.
80,000.
80,000. All right. Okay. Okay. Now, if you look at this, let's now draw the cash flow diagram. Let's now draw the cash flow diagram. So if you look at it, it's ramping downwards. All right. Okay. Okay, cash flow diagram. Let's now go ahead and do the cash flow diagram. I'm going to start my drawing. Seven years, right? Okay. 1, 2, 3, 4, 5, 6, 7. Okay, initial cost, what is our, oh, let me just put down the timeline over here. 0, 1, 2, 3, 4, messed up. Okay, initial costs would be how much? 200,000? Oh, 250,000. Thank you. Yes, thank you. Negative 250K. Yes, thank you. The negative is very important in this case, right? Thereafter, it does some savings. It does some savings. It starts off with a big saving. It starts off with a big saving and gradually becomes smaller along the way. Yeah, would you agree? Right? It starts off with a big saving and gradually becomes smaller along the way. All right, there's a catch over here. Okay, so that would be 200K savings. All right, 200K. Then this was 180K. Right, then you have all the way at the end, you would have a savings of just good old, just a plain 80K. And over here, well, maybe 100, I guess. Yeah, and you guys can see what it looks like. Right, and okay, now let me just save this picture. Let me clear the screen. Close that. Okay. All right. So this is what our thing looks like. Now, let's go back to some of the conditions of G. Let's go back to some of the conditions of G. Right? If you look at it, what does this look like? If you look at it, it looks generally like a G, a arithmetic gradient. But there's some catches over here. Yes, you're right. It looks like G, but Amit is saying it looks like an inverse of G. Amit, you are right. Both of you guys are right. The basic answer is gradient, but the more complex answer, it's an inverse gradient. Well, the whole idea of gradient is that it's supposed to be the whole idea of gradient is that it is supposed to be curving. It's supposed to be going, you know, it's supposed to be gradually increasing. It's supposed to be linear and it's supposed to be increasing. Let's go back to our arithmetic gradient problem which we did last week. There we are. We have this problem. Now, some of the rules of the arithmetic gradient is that number one, it has to be linear. That means it has to increase by the same amount all the time, right? Okay. It has to start from $0 at 1 at interval number 1, right? So that's why my catch is it can't be decreased, right? It can only increase. Let me correct that over here for you guys. So just make sure that you say that it only increase. It can only increase, because obviously look at point number 3. Look at point number 3. This is the most important point. The point number 1, everybody knows that hey, if it's a gradient, it will be linear. Point number 2, you will ask me, why did I cut off decrease? Can you see I've cut off decrease over here? I said it can only increase. And that's because if you look at point number 3, in point number 3 I'm saying it's going to start at $0 at interval 1. $0 at interval 1. Alright? Okay. So, oh well, we can say decrease over here. So the main maybe it can either increase or decrease, but it's going to start at $0. The point, it's going to start at $0 and it's going to start at interval 1. All right. So let's have a look at this. What problem do we have over here? We have, is this abiding by the rules? Let's go and have a look over here. Is this abiding by the rules which we set out? No, because it's actually gradually decreasing. It's gradually decreasing, and it's not starting at $0. It starts at a big number, it's going down. If it started at 1 and it went downwards, that would have been fine. So now we redraw this, okay? So that basically this piece equals to, that is the same as, okay, the above can be, we have to think of things, right? We have to think of other ways of redrawing it. So have a look at that particular problem which we did over here. Okay, we redrew this into this particular form. We split it up, right? So let's now see what we can do. Let's now see what we can do. We can say that our particular, this thing here, right? Okay, can be represented as, 2 as a combination of 2 cash flows working together, like our earlier example. All right, so let me redraw this thing here. Let me show you what we can do. Let me just minimize that. Okay, and let me show you. All right, let me redraw. Okay, I'm opening my drawing canvas. So what we can say is, we can say that this guy here is equal to, let me put an equal sign over here. We can say that it is equal to 2 cash flows, like what we did earlier on. 1, 2, 3, 4, 5, 6, 7. Okay. I want to draw another one over here. 1, 2, 3, 4, 5, 6, 7. All right, and let's put the text down. 0, 1, 2, 3, 4, 5, 6, 7. Okay, 0, 1, 2, 3, 4, 5, 6, 7. All right, there we go. Okay, and the first thing I can maybe say that I have an annuity. Can you see it's going upwards, right? An annuity of what do you think should the annuity be, guys? Well, okay, there's a lot of ways. To be honest, guys, there should be there are a lot of ways of doing this. This is one way to represent. Basically, we want to break this up into two pieces, right? Okay, annuity of 200,000, right? And minus a particular gradient. And remember what the rule for gradient is? The gradient rule is that it's got to start at the gradient rule is that what does the rule say? That your 1 has got to start at
$0 at interval 1.
Yes. All right. Okay, there we go. Okay. And along the way, of course, we have all these little gradients, okay, which I have not exactly drawn, but you guys get the point. And that would have a G. That would have a G what would the G be here over here be? What would this G be? Yes? Anyone? Yeah, Tavake. You're right, Tavake. G of negative 20K. All right. The G would be of negative 20K. All right. Okay. Because it's going to increase, and obviously the final amount. If you want to comment, you don't really have to. You can say that the final amount over here would be well, it starts off, yeah. So when you do this, let's now sit for a while and absorb this diagram. Can you see how these two diagrams are interrelated? Can you see how these two diagrams are linked? Okay, so this is equal to this. Does anybody have well, look at this guy. Amit, you've got a valid question. I like your question. in the end, we want to build a cash flow which looks like this, but it has to, we have only got 3 tools. We've got the annuity tool, right? We've got the gradient tool, or we've got the present value and future value tool, right? Compounding and discounting. So which one should we use? So we can use a combination of those tools. And so if you look at it, if you look at the cash flow diagrams, okay, if you look at the cash flow diagram, what we find is if you look at these cash flow diagrams, what we find is that this 200K, right, minus 0 at interval 1 is still 200. No, Amit, Tavake, no, have a look. Let's go interval by interval. Let's do this. Let's prove this particular diagram interval by interval. Okay, let's go. So Tavake is saying negative or positive. Basically, that's where the contention is. 200 at interval 1, 200, right? 200 interval 1. We've got to hit 200, right? At interval 1, we've got to achieve 200. Look at where my mouse is. Yeah, I hope you can see my mouse going round and round. Okay, interval 1, 200 minus 0 equals 200. Interval 2, we've got to hit 180. Interval 2, 200 minus, what is this over here? 20 gives you 80, right? Oh, okay. That's what you want to say. Yes. So maybe in our notation, when we've drawn our diagram like that, we don't. This is just our particular notation that we've got negative 20K, but the diagram is saying that, right? So yes, you've got a point there. You've got a point, Tavake. So maybe you can, if for those of you who want, the easier thing to avoid confusion, we can remove the 20K, but when we are doing your calculations, we should put the minus sign there, okay? We should put the minus sign there. So let's go to the last one. 200 minus, that's 20, 40, 60, 80, 100, 120. 200 minus 120 equals 80K, and that's 80K over here. So that diagram is correct. Now it's all thing. Okay. No, Amit, it's better to point it downwards because we've got to, you see, the cash flow diagram in itself indicates the direction of cash going in or cash going out. The moment we put the cash pointing upwards, then we basically show that cash, that's income coming in. Okay, all right, that's income coming in, but it's actually income going out. All right. Okay, and maybe yes, in the diagram we put positive 20, but we show it in this direction. But in our calculations, we should make sure that we have that corrected. Okay, let me just clear this up and then insert the diagram. In fact, if somebody finds another way of drawing this, that's perfectly fine. You might even find the same answer. All right. Okay, but make sure the convention is followed, that cash is going out or cash is going in. All right. Now, okay. So let's now call this guy here. Let's now go ahead and represent the guy on the left-hand side. All right. Okay. So okay, so our annual worth for project B, for device B, is equal to, that will be going down into three pieces. Firstly, it will be the first cost, okay, the annual worth of the first cost, right? Then we have the annual worth from the 200K, okay. Then we have the annual worth from the G. Okay, so it's three pieces. I think everybody should be in agreement with me. Okay, let's first now calculate the annual worth from the first cost. Okay, in order to calculate the annual worth from the first cost, remember the first cost was 250,000. In order to convert that, what do we use, guys? We use find A given P. Yes, yeah. Okay, let's use A given P. Okay, we use A given P, and our P value is our P value is 250,000. Our MARR, what is our MARR over here? Is 10%.
10.
Okay. Okay. So let me just maybe put this down over here. $250K into A/P value of 10% at interval of 7 years. All right, 250K, that's 0.1, 0.1, 0.1,
7.
10 years, 10 years. Oh, sorry, that'll be 7.
7 years.
7 years. And the answer is, everybody in agreement with Amit over here? Anybody else got the same answer? All right. Okay, so this is the from the first cost. Okay, this is from the first cost. Okay, set. Yes, very good. Thank you. There has to be a negative there, a negative. All right, thank you. Right, Amit? Okay. Right, now let's now look at the 200K. What is the A from the 200K? What is the A from the 200K? Guys? Well, it'll be 200K. Right? 200K, no changes needed. Nice. So that's our work done for us. Now let's look at the third one. Let's now calculate the A from the G. The A from the G, what do we use, guys? What would we use? We use A given G. A given G. All right. Okay, let me just copy this. Okay, we use A given G. So our AG will equal to G into A given G, which is, what is our G in this case, guys? Our G is 20K. Well, in our formula, we've got to use minus, all right, negative at a rate of 10%, 7 years, minus $20,000 at a rate of 10%, 7 years, rate of 10%, 7 years. What do we get? All right, Amit, somebody's laughing. Okay, any mistake over here, Amit, John? Let me know. Okay, so over here we have our okay, A given G. All right, in the end, our annual worth from device B is equal to the first cost one, okay, plus 200K plus
negative 500.
right, and the answer is $96,000. All right. So we've done our calculations. That's all good. We've done our calculations. Okay. What can you tell me? Let's read the question again. What device should the firm approve at their MARR of 10% using the annual method of analysis? Which device? So let's now list it out, what our results are. Device A has an annual worth A of this much,
3725.
right? Device B, okay, device B has an annual worth of $96. Okay, so now that we compare, which device should we buy, right? Purchase device B as it has a greater positive cash flow. That is our answer. Okay, both of them have positive cash flow, but device B has greater than device A. Okay, all right, guys, that's how you do this particular question. All right, okay, let's now have a look at this the same sort of question. In this particular question, I could have easily asked you to calculate everything in present width, right? But what we did was we had asked you to do it in from an annual width point of view, right? We can again another variation of the question. Let me put it over here, and that's for your free time. A variation of this question is to find the present worth of the two devices and compare. Okay, so make sure I'm not going to do that for you. I would like you to. Go ahead and give that an attempt. Okay, let's move to the next question. Okay, right. In this particular question, we are given 4 different lathes. Lathe 1, lathe 2, lathe 3, lathe 4. All right. We are given 4 different lathes, and we are required to find which lathe should be chosen. Right, let's go ahead and calculate this. All right. So basically, lathe 1, okay. All right, now let's have a look at the first cost. First cost is equal to how much, guys? 100,000. Annual savings,
$100,000. 25,000.
$25,000. Okay. Right. Let's now draw the cash flow diagram. So it is annual savings. So very simple sort of stuff. We have let's draw the cash flow diagram. There's a lot of drawings in this particular problem. I didn't like this problem because it takes a long time. Hey, what was the lifetime, guys? What was the life of the thing? Life. Useful life is equal to 10 years. Useful life is equal to 10 years. Any other information which I'm missing? MARR 15%. Okay, let me just put it down that way. Okay, it needs to highlight that as sorry. Okay, let's see. Tavake is saying, sir, for the questions like this, can we choose any method if it's not pointed out? Yes, yes. Tavake, if it does not say what to use, then you can use any method. Because both methods, whether we use PW or AW, whether you use present worth or annual worth, you can use any method to determine the particular which lathe is the best lathe, right? But in this particular question, I'm trying to demonstrate to you the particular method of annual worth. Okay, I'm not going to draw all of it, so we do it like this. 10, 9, 1, 2, 0, 1, 9, 10. Okay, now the first cost is $100,000. $100,000. See, we put this negative here. It's not for us. I mean, it's so that to indicate that it's a cost. All right, just like how we did for the G. Doesn't mean that you do a double negative over there. Okay, now the annual savings. Okay, savings is equal to 25,000 per annum. Okay. Okay, nice. We've got our cash flow here. Set. All right. Now, so what do we use in order to find the present worth for lathe for lathe number 1? What do we have to do? We have to find the present worth from the first cost. The present worth from the first cost, right? Plus, we've got to find the present worth from the annuity, right? From the savings. Maybe I put savings here. Savings. All right? Okay, fair enough. Okay, now, what is the present worth from the first cost? The present worth from the first cost is present worth from the first cost. Anyone? What would that be? Yes, Tavake. Very correct. 100,000. All right. Now, what would be the present worth from the savings? The present worth from the savings would be achieved by doing P given A. All right. P given A. Okay. So the present worth from the first cost P given A. What is our A over here in this case? Our A is 25,000. 25,000. Our MARR is what? 15%, is that correct? MARR is 15%. And our useful life is 10 years. So we have 25K, your MARR of 15%. 15%, 15%, at 10 years, 10 years. Answer. Students, anybody got the answer here? Oh, what am I missing? What is the answer? What is the answer? Answer is, yeah, the answer is yeah, okay. So we have an answer of 101. Okay, all right. So that's our thing. But remember, our present worth is equals to that plus that, which is equal to minus 100,000 right, plus this, and our present worth for our device 1 will become positive 25,000. All right. Okay. So present worth of device 1 would therefore be just this much. Okay. All right. Let's now do the same sort of analysis. Let's now do the same sort of analysis, but for device 2, right? And we don't need to redraw each and every time. We don't need to redraw each and every time. You draw one, you know, I mean, I'm not going to draw it, but it's good if you draw it for your notes. But there's really no point in me redrawing it, but because we're doing the same sort of calculations now. Okay, now P2, what can somebody tell me what for lathe 2, for lathe 2, what was the first cost? 150,000. Annual savings of
34,000.
34,000. Useful life of 10 years. MARR is still the same. All right. That will be negative 150. This is 34. This is 34. Everything is same. Can you tell me what is this one over here? What is the P first cost for your second device? Maybe we need to do this P2 first costs. P2 dash, yeah. P2 first costs. P2 savings. P2 first cost. P2 first cost. P2 savings. P2. Right, what do we get, guys? 170,000. 170,000. Now we have P2, P2, P2 minus 100 and what is it over here? 150, and you've got 170, and answer is 2006. Okay, all right, P2. Let's now do lathe number 3. Lathe 3. All right, I'm going to try and finish this within the hour. 200,046. You guys can race ahead. All right, if you want, you can go, because you guys are probably 200,000 and what is it? 46. You don't have to wait for me. You can calculate in your exercise book. Right, so this is 3, 3, 3, 3, 200, 3, 3. This will be 46. This will be 46. Can you see this answer? This whatever is in the brackets. Do you notice that it is still the same? All right. What do we get, guys? Anyone? $230. Guys, those of you who've got to go to class, you can go ahead to the other class. But we will finish off this problem here, and I will, it's the same. It's basically we've done the calculation. We're just doing the comparison. This is 200. All right, and this is right, and what do we get? This is P3, right? P3, 3, 3, 3. Answer, final answer. 30,000. Okay, can somebody tell me just the answer? We won't do the calculations. Can somebody tell me just the answer for number 4? All you have to do is basically change this value in your calculator and change that value. Lathe 4. Anyone done lathe 4 yet? What is the A for lathe 4? Okay. 52, 55 and 55. $255 and 55. Is that correct? 255 and 55. Final answer? Amit, is that your final answer? I think somebody's watching TV in the background. Okay. Oh, present worth is 210. Okay. Or not 210, 21,000. Alright guys, now let's have a look at all our answers. Let's now compare. Let's now compare. Right, so lathe 3. Why lathe 3? Why? You can't just say lathe 3. You have to explain your answer. Because it has a higher present worth than the rest. It's making you more money, basically, right? It's making your company more money, and that's your final answer, right? It is the highest, all right, compared to the rest. That's it for today. We'll finish off our lectures now. It's already 2 o'clock and we have a 1-hour session. Thank you for attending. We will meet again on Friday. All right, please take note of the deadlines for the lecture transcripts, and if you need an extension, please email me. All right, thank you so much and goodbye.